Amazing light comes down to some glass, a little metal, a dollop of gas, and one relatively simple chemical reaction. Turning a bulb into the electric light involves a mesmerizing dance of the machines. This elegant, beautifully choreographed industrial process brings together the glass stem, the leading wires, and the holding wires. And all of these will hold the tungsten wire in place. The stem is heated to melting point. The wires are added. Then it is clamped and gradually cooled to reduce the chance of cracking. Now the stem can be married to the bulb. All that's needed is the tungsten filament itself. Tungsten is the only metal capable of producing light continuously. Any other metal withers after minutes, or at best a few hours. And astonishingly, it's not changed as the main ingredient of the light bulb since Thomas Edison perfected its potential more than 120 years ago.
The filament in the light bulb is made of wire. When stretched, it's a metre long. People don't realise how many machines and complex processes are needed to make it.
The problem has always been that most metals melt before they reach the high temperatures needed to produce light, or they burn out too quickly. But not tungsten. Tungsten shines white when heated at 1300 degrees Celsius. The problem with tungsten, however, is if it's anywhere near oxygen, it won't work. This is why the bulb is crucial. It keeps it in a vacuum. And just to make sure that the tungsten continues to shine brightly, it's dipped in gether, a chemical that will burn off any remaining oxygen inside the bulb at the moment it's first lit. And now for our marriage ceremony. The stem and the bulb are finally joined together. Once the bulb is sealed, a gas called argon is pumped in. This pushes out any remaining oxygen and increases the life of the tungsten. But it's not foolproof. There's still a chance the oxygen will find a creepy corner to hide in. The bulbs still have no fitting, however, so it's time to fit the metal base of the bulb, known as the cap. Just before the bulb is lit for the first time, the cap is fixed and welded to the lamp, and the contacts are soldered on. If the process has worked, there will be a puff of smoke from the gether, and the bulb will be oxygen-free. If not, the bulb will blow. Witness the birth of the bulb. Factory manager Grzegorz Lizincik prowls the plant listening to the song of all the machines at work. And there's something he finds amazing.
Every day I watch the product that has been around for 120 years, and every day I wonder why it's changed so little, whilst the production process has changed so much. So much time, so little changes.
But change is on the way. For all its brilliance, the conventional light bulb is, by today's standards, very inefficient. It's an energy-sucking device that converts just 5% of electricity into light. The remaining 95% of the energy is wasted heat and infrared light. Other kinds of bulb are being designed to be far more efficient. Fluorescent bulbs last 20 times longer and give off 75% more light. Light bulbs of the future could depend on the same chemical that keeps nappy rash at bay, zinc oxide. This could help convert electricity to light 10 times more efficiently and last 10 times longer than the conventional bulb, reducing the planet's electricity consumption by more than half. In the US alone, that's a saving of $35 billion a year. So soon the classic, traditional light bulb could be phased out altogether. Even within their lifetime, the people who've made this deceptively simple masterpiece could be talking about the light bulb as a museum piece, an antiquated icon of the 20th century. 5 ordinary objects, 5 extraordinary stories. Coming up, another essential component of the modern world. So basic to modern daily life, it affects pretty much everything we use. The secrets behind steel. Next, on How Do They Do It? Steel, like concrete, is an absolutely essential part of our lives. Even when a product isn't made of steel, you can bet steel was involved in designing, producing, and distributing it. Just as bronze and iron defined previous ages of man, so steel defines ours. We rely on it so heavily, but few of us know what it is and how it's made. So how do you make the product that the world can't do without? How do they do it? In fact, there is no natural metal called steel. To make it takes a kind of modern-day alchemy. And it all starts with iron. Iron is the basic ingredient of steel, and it's found in rock. Rock that is rich in iron ore is mined all over the world. It's ground down and shipped to steelworks. And in the English town of Scunthorpe, it takes 4 queens of England to turn it into steel. Introducing Anne, Mary, Bess, and Victoria. These are the 4 furnaces of the Chorus Steelworks. And here, pulverized rock begins a journey of transformation. Iron ore is basically iron oxide, or iron chemically bonded to oxygen. The problem is, to make steel, you need to get rid of the oxygen and separate the iron from the rock. To do this, you need to melt the rock. The iron ore is hauled up to the top of the furnace in containers the size of garbage trucks and then dropped into the furnace. Then a huge amount of hot air is blasted up through the iron ore, and this is where a blast furnace gets its name. The rock is melted at a temperature of 2000 degrees centigrade. No longer iron ore, now it's molten iron. From here, the iron is poured into a train. No ordinary train, of course. This is called a torpedo. It's specially insulated to carry the 1500 centigrade molten iron. Every day, 10,000